Sizing cable trays that contain mixed voltage cables requires careful consideration of the National Electrical Code, specifically Article 392. The approach to sizing the cable tray involves several key steps. Firstly, understanding the spacing requirements for high voltage cables is important. In this case, 4160 volt cables are present in the same cable tray as 480 volt cables. According to NEC 392.80 BOEM, when dealing with high voltage cables, specifically those operating at 600 volts or higher, a certain spacing must be maintained. The code mandates that these high voltage cables be spaced with a maintained spacing of not less than 1 cable diameter between the cables. This spacing is crucial for ensuring proper ventilation and effective heat dissipation. High voltage cables generate more heat during operation, and without adequate spacing, this heat can build up, potentially leading to insulation damage, reduced cable lifespan, and even fire hazards. Secondly, after addressing the spacing requirements for the 4160 volt cables, the next step involves calculating the remaining usable width of the cable tray. The initial tray width, which in this scenario is 36 inches, is reduced by the space occupied by the 4160 volt cables and their required spacing. This calculation provides the effective width available for the remaining 480 volt cables. Thirdly, once the remaining tray width is determined, the focus shifts to the 480 volt cables, specifically the smaller than 4/0 American wire gauge. To ensure compliance with the NEC, one must refer to Table 392.22a. This table provides guidelines on the maximum allowable fill area for cables and cable trays based on the tray width and type. The goal is to determine if the sum of the cross-sectional areas of all the 480 volt cable smaller than 4/0 American wire gauge fits within the allowable fill area specified in column 1 of Table 392.22 for the calculated remaining tray width. This step ensures that the cable tray is not overcrowded, which could lead to overheating and potential safety hazards. By following these steps, one can properly size a cable tray that contains both 4160 volt and 480 volt cables, while adhering to the requirements of NEC 392.22a for ventilated cable trays with multiple conductors and cables of different voltage ratings. This approach ensures that the cable tray is appropriately sized to accommodate the cables safely and efficiently, while also complying with the relevant electrical codes and standards. It is also a good idea to consult with a qualified electrical engineer or inspector to ensure compliance with all applicable codes and regulations, as well as to address any specific concerns or questions related to the installation. By adhering to these guidelines, you can ensure that your cable tray system is safe, reliable, and compliant with all applicable codes and standards. Additionally, consider factors such as the type of cable tray, the environmental conditions, and the specific requirements of the application when sizing a cable tray. Also, be sure to properly support the cable tray and to use appropriate cable ties or straps to secure the cables within the tray. Proper cable management is important for ensuring the long-term reliability and safety of the cable tray system.